Hello, folks. Welcome to session 3 of the OKN Open Knowledge Network track A2. This is the KnowWhereGraph project. And this session will be about initial applications of the KnowWhereGraph. My name is Mark Schildhauer, and I'm a co-PI on the project. In this session, you'll learn about 2 of our initial use cases or applications. Involving collaborating with partners working in disaster relief and in the farm and food industries. We'll hear from Ana Lopez-Carr, who's the monitoring and evaluation specialist at Direct Relief, about how the KnowWhereGraph assists Direct Relief personnel in identifying experts to consult with in the case of impending or ongoing disasters. Ana Lopez-Carr will be talking, and I'm Mark Schildhauer. Then you'll hear from Dr. Colby Fisher of Hydronos Labs, and Oliver Wyman, who will describe how KnowWhereGraph is working with partners in the farm and food industries to semantically link diverse data with geospatially detailed information about food and crop security and safety to address, for example, how climate change might impact crop production in different regions. But first, I'd like to provide a little technical background about our KnowWhereGraph. Firstly, the KnowWhereGraph is a graph. And what does that mean? It means it's a type of database, but it is not structured like your more conventional table, like in a spreadsheet, a CSV, or even relational databases. It's got this graph structure. And the graph structure consists of nodes and links. So here we have a node that is linked to another node. And that node link node structure is called a triple or a statement. And they also talk about it being a subject, predicate, object. So the KnowWhereGraph currently consists of over 12 billion of those sort triples. And it is built according to W3C recommendations for the semantic web, which is really cool because it also uses web-based URIs to identify every node and link, making our graph highly machine actionable, interoperable with other graphs, and the semantic web recommendations enable all sorts of advanced semantic features like symmetry and transivity. The graph technology we like because it's expressive, it's extensible, it's flexible, and it's very fair compliant relative to the data we ingest into the graph. So if you haven't heard about graph databases, they actually are the underlying technology in a lot of the famous internet services, which I'm sure you've used, like Google and Netflix and Wikipedia. But why do we call it KnowWhereGraph? Well, because our graph is coupled with a discrete global grid system. And what that is technically, it's a hierarchical S2 cell tessellation. And if you look at that map, you can see that you can divide up the globe into these consecutive little cells, each of which has its own identifier. And this enables us with the KnowWhereGraph to address all sorts of queries about data about where did this happen? What else might have happened here? So there's a lot of geospatial intelligence in the graph. So without further ado, I'd like to hear from Ana Lopez-Carr about the collaboration between KnowWhereGraph and Direct Relief. Thank you.
Thank you, Mark. I'll share my screen. Can everyone see that? Great. Good afternoon, everyone. My name is Ana Lopez-Carr, and I'm from Direct Relief, a humanitarian organization located here in Santa Barbara, California, that focuses on providing medical aid and emergency response for global disasters. Today, we'll demonstrate how the KnowWhereGraph can help us respond to humanitarian disasters by providing solutions to our data needs. We'll use Hurricane Harvey as an example. Hurricane Harvey made landfall in Texas and Louisiana as a Category 4 hurricane in 2017. 100 people died as a result of that storm, and it became tied with Hurricane Katrina as the costliest hurricane on record. 30,000 people were displaced and 17,000 more needed rescue. Direct Relief was there to provide assistance. And while our expertise lies in the logistics of sending medicine and medical supplies to disaster-affected areas, each disaster, and in this case hurricane, presents a set of important questions which are outside of the scope of our core mission. When we're developing our risk and vulnerability analysis, we rely on outside expertise and data sources for things like weather forecasting, disaster risk modeling, demographic data, public health hazards, and even health infrastructure capacity information. All of these things have potential impact on human health. Currently, we piece together data from public sources ourselves and put all of that into a GIS platform. But that takes a long time when time is really of the essence. A knowledge graph would give us greater efficiency in identifying useful resources and understanding the relationships between these data. Direct Relief has focused its efforts on assisting health facilities that serve people who rely on the healthcare safety net for essential services. In the storm's aftermath, it's been critical to support the existing nonprofit health centers that provide services to the people who really are the most vulnerable. These facilities and their patients need help to recover during the critical period after storms like Harvey. Direct Relief provides medical and cash assistance to these clinics so that they can better serve their communities. But we can improve how we send our cash and medical aid with expertise knowledge. Relying on expertise knowledge at that critical moment helps us understand the risk factors and the local medical needs. We want to know about potential communicable diseases. A hurricane can leave behind a lot of stagnant water, as you can see. So waterborne diseases are a real concern. Working with epidemiologists who can quickly charter those risks is important to our response. Similarly, environmental hazards and infrastructure damage can easily feed into a health hazard situation. We would need experts to describe to us the potential impact of toxic waste or chemicals in a community, or how power outages may impact relief and medical efforts. We also need to know all sorts of things about the displaced population, like their demographics and location, and what kind of chronic diseases might need attention. So you can see that there's a lot of branches of knowledge that we need to follow as the disaster unfolds, and having those experts and data ready at hand through the KnowWhereGraph would be incredibly useful. Helping communities recover is also an important part of our work in humanitarian aid. And in the days, weeks, and months after a disaster, the needs of the community change. Often this phase requires expert knowledge, and our focus, though it remains on health systems and in providing medicine, it might also require supporting the health needs of a facility with their clean and renewable energy resources, or their cold chain capacity for medications such as insulin, or even just repairing their infrastructure. We also want to be sure to learn from past disasters when responding to current ones. What kind of disasters or health emergency occurred previously in the current area of interest? What was the emergency response like, and what were those lessons learned? Having historical disaster data helps us build simulation models that can then inform our future responses. So how does the graph help us do this? How can we get that data quickly and find experts we can talk to? In order to assist us in planning for and responding to disaster events, we've partnered with KnowWhereGraph to build an expert discovery system with the flexibility to find experts in the field based on their expertise, location of interest, and prior experiences. So in this demo, we'll show you the most current version of the expertise graph. When opening the application, the user will immediately see several major hurricanes from recent years displayed on the graph. But perhaps we're looking for something more. The graph actually contains information on US hurricanes dating back to the 1950s. You can see the full list from the search bar and find all the included hurricanes with key information for each storm. or you can type the name of the desired hurricane directly into the search bar to find it. Once you've selected your storm, in this case, Hurricane Harvey, its trajectory will display represented by the green line. The yellow circles show the estimated impact area of Hurricane Harvey, and this data comes from NOAA impact records, which are available in the KWG. But now we want to dive deeper and learn more about Harvey's impact. From the search bar, you can select to display additional data related to Harvey's impact area. A choropleth map layer will display showing data at the county level. On the legend on the right, we see some key disaster statistics such as property damage, injury, and death for the affected area. The property damage legend provides the key to the colors on the map, with darker counties representing areas of more costly damage. We can also click on the legend to display other variables such as direct death or direct injury. This changes the data range on the color bar at the bottom as well. The legend also allows us to explore health variables for the impacted area. We can explore diabetes rates or mental health variables, for example. We can also explore the choropleth map directly. Here we can hover over a county and find out how much property damage it suffered. You can do this for other variables as well. On the bottom left, we see a tool that shows cascading disasters resulting from Hurricane Harvey and the property damage from each. Hurricanes can cause many other resulting disasters, and the graph allows us to explore these events in a disaggregated manner. Here we can see flash floods, tidal surges, tornadoes, other floods, and the cost of the damage attributable to each. We can click on the sub-disaster fields and the map will show related property damage by county. A scatter plot is also available for users to explore the distribution of two statistics at the same time. The colored dots represent different sub-disaster types from the list below. The scatter plot contains variables from the legend on the right. Here in this example, we see diabetes rates and property damage displayed on the scatter plot, but we can choose from any other combination as well. This data is at the county level and is also tied to the choropleth map on display, so we can visualize these relationships geographically as well. The scatter plot is interactive, meaning I can select a subset of data displayed in the plot directly, and the map will filter automatically. In this example, I'll select dots from the upper right quadrant to see the counties that have the highest rates of diabetes, as well as the highest amount of property damage. I can hover over a county to see more information. If I click on the county, a window will appear, giving me an impact report and health profile for the county. We can see that the county has suffered $1.5 billion in damage, and that over 45% of its population is clinically obese, and that 16% of residents have diabetes, and another 16% lack health insurance. This starts to give me a good idea of the needs of this population, that they might have in the aftermath of a disaster. But now I need to speak to an expert who can answer the questions I might have about the impact of the hurricane or the health of this population. I can quickly search for hurricane experts, for example, by going to a drop-down list in the search bar. A widget will appear that allows me to search for additional expertise, such as those related to health. But for now, if I search for hurricane experts, the map will display the location of individual experts. I see that there are 4 located in Texas, either inside or adjacent to the impacted area. By clicking on the Show List button, I can see the full list of experts available in the graph, categorized as local or non-local based on their proximity to the impacted area. I can scroll through the list and find more information about each expert, as well as a link to their website. I can go back to my search widget and select for experts with expertise in diabetes and obesity. These experts will also display on the map. I see that there's one, and that is Stephen Ponder, who is located near the affected area. When I click on his name, I see his affiliation, location, and research interests, and a link to his webpage. Stephen is someone I'd probably contact to find out more about diabetes in the area. As you can see from this demo, within seconds, the graph can help us with our risk and vulnerability analysis. We can gain situational clarity by finding experts who can speak to the health risks at hand. Those same experts can also help inform the recovery and resiliency phase of our response. At Direct Relief, we look forward to exploring these data through the graph and improving our situational analysis and emergency response. In the future, our goal is to keep expanding the graph to include things like other disaster types, like earthquakes and wildfires, international data for places where our understanding might not be as great, and global infrastructure data to improve our situational analysis in foreign countries. And with that, I've concluded my demo. I hope you've enjoyed it, and I will hand it off to my colleague, Colby Fisher. Thank you.
Thanks. Let me get my screen up here. We're going to switch gears a little bit now and talk about use cases we've been developing with the KnowWhereGraph in agriculture and the food sector in general. Thumbs up on that. Good. Okay, cool. All right. So as I said, we're going to talk about agricultural land, supply chains, and sort of the idea of food safety, security, sustainability that comes from that, derived from the data that is in the KnowWhereGraph. This is myself, David Smith, and Mike Mathias through Hydronos Labs and Oliver Wyman, and of course, working with all the KnowWhereGraph folks. So what are we trying to do here? Well, we're trying to address a broad challenge, which is the idea of food security and safety, which is becoming incredibly more important, right, as we see what's happening in the world at the moment. When you try to do that from a data perspective inside of any of the industry domains that we have there, you find that what we need to do is bridge across a whole bunch of different topics, and those are really sort of data topics. But those data tend to be siloed, really distributed, and you know, sometimes variously and sometimes dubiously described. And so what you see on the right there is all sorts of pieces of data that we want to collect when we're doing analysis on food security and safety and the food supply chain in general, right? And that comes from domains like soil data, agricultural information from the farmers themselves, environmental data, and then tons of logistics and supply chain data from the industry players themselves. And so what we really need there is some solution that allows us to link amongst all of these things, allow us all to talk a common language, and you know, be able to interact with our own data that we have personally when we're doing this analysis. And so that's really combining the graph technology with geo-enrichment. And we have the KnowWhereGraph. Excuse me. So what are we trying to do here in a more general context? Well, what we're looking for is building resilience in the food supply chain through data solutions, robust data solutions. And what we ultimately want to do is be able to handle disruptions to those supply chains. So we've seen a lot recently around our general supply chains getting disrupted. Here we're looking to sort of solve that or address that through data. So our pilot is looking at how we can assess and predict and handle the disruption and coupled impacts that come from you know, different shocks inside of the food supply system, everything from natural hazards, hurricanes, earthquakes, to things like the COVID pandemic. And so what we're trying to do is leverage, as I said, this cross-domain intelligence through the KnowWhereGraph with all sorts of different data sets, as you've seen before from what was previously shown, largely leveraging public and private data, tapping into all sorts of public data, which I'll show in a moment, around environmental conditions and agricultural conditions. And then at the end of that, as we work with our partners, we're combining that with some of their private data around the supply chain. So things like transportation, logistics, locations of facilities, you know, individual infrastructure inside of there to look at the risks and planning that's needed when something happens. And then finally, as we go through this, I think you'll see there's opportunity to use the same methods and things that we've built beyond just sort of the agricultural industry and the food supply chain, thinking more broadly about environmental and social governance issues. The KnowWhereGraph is really providing these area briefings to know anything about a place in seconds of a query. And if you want to do that in an environmental sense, you can start to do some really cool analysis on the environmental implications located for facilities and you know, co-location of assets like that. So how are we doing this? Well, first, we're doing it through close partnerships with our industry players. So the first one of them is the Food Industry Association, FMI. They're sort of our first partner in this space. And we've really been working with them a lot around looking at how we can do crisis management, hazard mitigation when events happen. And that's the first thing I'll talk about in a moment here. We've segued from that into a broader look at how we can use the KnowWhereGraph to sort of increase speed and efficiency when dealing with emergency response situations, again, kind of focused on the natural hazard space, but really looking at how we can use this sort of linked and leverage data to leverage, you know, everything that's there, allow for easier communication, disaster mitigation, preparedness, response, and recovery planning. And I think you'll see the connections there as we go through it. And then finally, we've been working in the farm credit space, again, using the same agriculture data for a totally different application, which is doing this sort of perspective valuation of land, looking at all the different features of the land and how that correlates with the agricultural production, as well as sort of the value over time relative to the loans that they're putting out. And so I'm going to try to cover all these today. It's a lot of stuff, but we'll focus first on the FMI piece here. And so what we're really trying to do there is look at agricultural disruptions and how we can assess them and deal with them as a result of fires, as a first example, and other disasters. And the reason for that, as FMI identified for us, is that communities tend to become food insecure when there is a crisis or disaster happening. And that can be your local community that's affected directly by the event, and it can also be a broader, you know, national level impact or international level impact due to the complexity of our supply chain and sourcing things from areas that may be affected by fires. And so ultimately what we want to do there is identify through the graph these questions of where is our food coming from, when something happens, what's going to be affected by that, and then how can we plan for those disruptions in the future. And so the way that we did this is entirely using data in the KnowWhereGraph, build out a web interface that allowed the FMI members and end users to query the graph with no programming knowledge on their part or any real technical analysis to answer this set of workflow questions to address this one specific issue. And again, those questions are, where are fires happening at the moment? When we know there's a fire happening, what regions are being affected by the smoke and ash, because that directly affects the crops that are being produced. From there, can we identify, as I just said, the agricultural areas that are being affected by that hazard, and specifically what crops are being grown there? And then from there, getting more into the supply chain piece, what is the magnitude that this event is going to have on a crop production? So in this case, let's say lettuce, because the ash fall on the lettuce essentially spoils it. And then who's going to be affected by that? That could be people that are affected or businesses that are affected, and we want to look through that whole supply chain. And then finally, once we know that, how do we alert the key stakeholders and try to do mitigation and or planning for future events? And what that really looks like from the data perspective is that we use the graph to query things like wildfire smoke plumes when we know a fire is happening. We then couple that with a connection to what agricultural areas are being affected. And we can identify that there are, in fact, lettuce fields that are inside of this smoke plume and that we think there's going to be an issue. And ultimately, we get to the point there of identifying regions that may have a tainted crop that we want to go and address. And just really quickly, you know, if you were in our original session today, you saw this sort of data list. This is growing all the time, but you know, these are some of the properties that we're tapping into from the KnowWhereGraph just for this specific example. And you know, we can come back to this if there's questions. So what this ultimately looks like is this web interface, and I'll just scrub through it quickly. So you can come into the system, you can pick a date, it's historical, but we're also trying to do this in near real time. So let's, you know, imagine that we're picking near real time in this example. This would show us at that moment, query the graph, all the wildfires that are happening, which is a lot in this case because we're using a large time span. But then you can drill down to those individual events that are the wildfires. You'll see that we query the graph there. We get some information about the wildfire. You could pull more than that if you wanted to. And then we move into the next step of the workflow, which is really just doing the get plumes part. And all that does, again, is correlating in time and space, query the graph for the smoke plumes that are associated with that event, and then push them back to the user so that they can start to see that. And you'll see on the graph here, we can scrub through time and pull more data from the graph to look at how the smoke plumes are changing over time. Depending on what your analysis level is, you could use this, or, it's a nice visualization of what's going on. We've also layered in there information around air quality, right? Because that has a strong coupling with the ashfall component as well as worker health on farms. So we wanted to enable them to be able to address those issues as well. Again, pulling that air quality data for all the stations available in the graph. And then finally, we get to the crop piece, which is done simply by clicking on one of these polygons that are the smoke plumes. And what that does then is send another query to the graph to figure out, for this region that we've identified, which is that red polygon there, what crops are being grown there. And so as we go through this here, you'll see there's a listing of all the different land types that are essentially underneath that. Lots of different types of crops that are growing there, some very small numbers, urban areas, all sorts of stuff like that, right? And so if we picked grapes, for example, because we were worried about tainting of wine grapes, what the system will do then is really just illustrate for you where all of those crops are located so that we can start to identify where there might be issues. What this is also showing is the S2 level, S2 cells that are representative in the graph, right? And so we have essentially crop data on almost field scale at this point of what is on the ground in any of these situations, which is really nice. And so that's great. But then, we're supposed to be working with these industry players. So what do we actually want to do there? Because we really just ended that by identifying where there's crops that may be affected. Well, we want to allow stakeholders to use the system, identify areas of interest that are relevant to them, and carry out their own analysis, right? And so what we ended up doing then is putting together a similar system to what you just saw, an extension beyond that, that allows a user to essentially define where they source their crops from. So being able to find and notify the facilities that they use, the retailers that are part of their network, determining alternative sources of the crops, and ultimately getting down to the population level. So what stores are going to be affected, who uses those stores, where is this all located, right? And so again, we built that inside of the KnowWhereGraph, with this web application on top. We can start from the same point that we were at before, and what you see here on this graph is the plumes that you saw before, as well as a number of other nodes. And these nodes are, anonymized at this point, but one retailer's network of resources. And this goes everything from processing facilities, which collect the crops from the fields, to the distribution facilities, so where things are sent out from, and then ultimately to the stores, right? And so as we click on the plumes, you start to see what you saw the last time around, which is an indication of the crops that are being affected by that smoke. But then we can drill down from there to the impacts on the specific network itself. And let me scroll ahead a little bit here. So when you keep drilling down there, what the system will do is allow for the stakeholder to see the stores, distributors, and processors that are actually being impacted by this event, all just by querying off that original polygon, right? And so this is the idea of sort of an area briefing. What's happening in this area and what is it affecting? And we can start to go through this, and the user can go through and identify where their assets are. In this case, it's showing the fields that are affected as well as the stores that are coupled to that. And the user can go through and manipulate this however they want to be able to really identify on a first cut level what is happening as a result of this event. And so we put this in front of some of the FMI members, and they thought it was wonderful, but what they actually wanted to do was extend it to a lot more than just wildfires, right? And so what we're doing at the moment is building out this idea of a general crisis navigator dashboard for these retailers, because when something is going on. There tend to be multiple issues across all sorts of different domains. So they're interested in wildfires, pandemics, earthquakes, floods, hurricanes, climate change, power outages. All of these things impact the food production system, the supply chain, and retailers, right? And so what we're building at the moment through the graph is this sort of multi-hazard navigator, right, which will use all the data in the graph to identify what is happening at the moment. And then, you know, again, using the wildfire example here, but allow you to then drill down to whatever the hazard that you picked is, all of your assets that are being affected by those events. In this case, right, we're talking about crops and food. And then ultimately get to supply chain adjustments and planning, depending on what needs to be done. And so what you can see here is this sort of end process, allowing the retailers who are using this system to identify, go through, find distributors that are going to have problems, and then source other distributors, you know, in simple color form that are going to be better sources for them. And so this is really just using the graph to do sort of rapid contingency planning from the data that is there. And so, you know, I'm going to go through this quickly. We're building this out, as I said, for multi-hazards, building in all of this data from the private sector and ultimately partnering with them to really build out this workflow on top of the KnowWhereGraph. Linked to that, though, is this idea of emergency preparedness. And what we're doing here is extending the same sort of system and workflows in a public sector space to look at situational awareness when hazards are happening. Again, very similar to what Anna was talking about before, so that the KWG can be used in aiding response planning. Our initial examples here are coming from this collaboration with the Central U.S. Earthquake Consortium and a couple other partners. When what we're really doing there is, instead of wildfires this time, we're looking at how we can use the KnowWhereGraph to assess impacts on the food system when earthquakes happen in the middle of the US. And then ultimately from there, how that can be used by agencies like FEMA, Homeland Security, to plan for providing food and water and safety for people when those events are happening. So doing, instead of supply chain logistics, almost, you know, emergency planning using all the data in the KnowWhereGraph. And that has a lot of parallels to everything I just talked about and that we developed from the graph for the private sector side before. I know I'm going through this quickly, but we can have a lot and we can do questions on this. The final thing that we've been doing on the project is a bit of a pivot, but we've been talking about looking at land valuation and crop growth assessment, essentially, from the graph. And in this case, we're using a lot of the data that we talked about before, except we're adding in more nuanced things beyond just crop types. We're adding things like soil and soil health practices, soil properties, more physical earth variables, things like soil moisture, and then coupling that in the long term with forecasts, medium-term forecasts and climate forecasts, looking at how the land is going to change over time with climate change, right? And that's pretty important at the moment for food production. And so ultimately what we're doing here is, again, building out the same kind of web tool in this space, but allowing users to go through a whole different set of questions, again, with little to no, you know, technical know-how on accessing all this disparate data, but ultimately being able to answer all of these questions, which are going from, I want to know where all the ag areas are in the US. I want to know where the almonds are being grown. I want to know all of the soil, water, climate conditions that go along with that, and how that's going to affect historical production as well as future production. And then with that information, what our partners are trying to do is essentially, you know, weight their loans and how they're putting that into the agricultural system towards more favorable conditions in the long run, right? Which makes sense because we want to ensure that our food supply is sustainable and that we're funding areas of growth that are going to persist in the relatively long term. And finally, I just wanted to highlight, you know, all of this stuff makes use of tools that you could have seen in the previous session if you were there, but the KnowWhereGraph team, if you go to our website, has some really nice stuff on faceted search, as well as GIS plugins that you can use to do a lot of the same kind of analysis that we're doing here, or, you know, you can build your own layers on top. And so I will just put this slide up, but I'll stop there and pass it back to Mark.
Thanks, Colby. It was great. So we just saw two of the hopefully compelling applications. These are initial applications of the KnowWhereGraph, chosen, I think, for their intrinsic diversity. So you saw the GeoGraphVis with assisting with direct relief, and Colby showing the Wildfire case application web service. So we do have about 8 minutes for any questions to any of us. And there's a lot of KnowWhereGraph experts on board. So basically any question is fine. For the direct relief use case, currently our experts were identified through a text mining extraction of information from Semantic Scholar. So our experts currently are somewhat weighted towards the academic region. Our future plans that we've discussed with the direct relief people is to try to expand that coverage to cover some of the social media information sources, which might have some more direct localized relevance, for instance, in terms of identifying the county director of public health, or a prominent local spokesperson for, homeless shelters, and, get some more immediate response data into the graph. So that's one of our future directions that we anticipate going with the direct relief use case.
Yeah, so Christoph put in the chat there, sort of talking about the development of applications on top of the KnowWhereGraph, and that's essentially what we've been trying to do in all of these use cases, right? And I know you can't see it when you look at it in a demo like this, but really the members of the team that have been developing these things have been able to build quite rapidly really useful applications right off the bat, just with simple queries to the graph. And I think when you couple that with whatever your own research group or company is doing, right? You may have your own software, your own stack. All you really have to do then is mix in essentially an exchange for data from the graph in one way or another. And of course, you can have two-way communication there on what is in the graph and what you want out of it. And you can super rapidly do things. I know I always give this example in the group, but I am a hydrologist, yet I don't really know anything about hurricanes. And I've wanted to know before all the hurricanes that have happened before in an area. And I can do that from the graph just with one simple query and get all the data that I, first off, don't want to spend the time going to find and cleaning up. And then secondly, don't necessarily know how to interpret myself. And I can get a really cleaned up, nice response of when these hurricanes have happened for the location I'm interested in. And to me, as sort of a practitioner, that's immensely useful.
I think it's also worth mentioning that in terms of, we mentioned FAIR, the findable, accessible, interoperable, reusable, and how KnowWhereGraph really has an emphasis on that. And a lot of that comes through the kind of consistent terminology that we're building with working through the Kansas State group at Pascal Hitzler's lab, as well as Shirley Stephen Ambrose at UC Santa Barbara, to build these ontologies. So for instance, our disaster hazard ontology is very strongly compatible, if not directly aligned, with the United Nations work on disaster risk reduction. And there's, for instance, a group at ESIP, the Earth Science Information Partnership Federation, that's working on a soil ontology. And one of the layers in Colby's graph showed the importance of some of the soil data that we'll be ingesting into the KnowWhereGraph. So that is something that we would hope to be able to use, that soil ontology, to facilitate interoperability with some of the other groups, say, that are also studying soil and members of the ESIP Federation. We also, I think, are looking forward, if you've attended some of the other open knowledge network projects, to interactions with both the urban flooding activity, as well as the scalable precision medicine activity. Both of those have obvious space-time connections that match so nicely with the geospatial intelligence capabilities of the KnowWhereGraph. So we're very interested in moving into linking these medical concerns, which have obvious relevance to direct relief, with the disaster after a flood and the types of, say, waterborne diseases that might ensue from that type of a disaster. So we see some synergies for working with some of the other open knowledge network projects. I see Jonathan, you've asked a question. Did you want to state it, or should I just read your?
I can ask it, but I was trying to be cautious and not, I understand the technology advancements you're pursuing here, and the demos, the way they're presented, it looks almost like a TV show, like you're at NCEAS and you're diving into a big database. And so it looks a little bit like Hollywood. And I wonder if you've got maybe other organizations who are not part of the team who've been able to test it to see if they have, if there's a usability issue. Because I know with just very simple ArcGIS applications, we have problems with people interacting with a map. So I could see usability being a big challenge in developing this.
Well, let me take a first stab at that, I guess. On our side, at least, sort of interfacing with the, sitting at sort of that public-private, industry interface, we've tried to do all of our design and build off of, direct interaction with the clients. And so when we're building those customized applications on top, which is really what you're seeing in all of these examples, we're designing them usually in a more modern way such that they're directly meeting what the client is looking for, and we're constantly workshopping it with them to build those out. I think when you get to actual interaction with the graph, writing Sparkle queries, code, and all that kind of stuff, I think you'll find that a lot of the developers and players in this space that make applications that are specific to their company or their industry, right, will have the necessary skills, because it's very similar to just interacting with a SQL database. And so if you can do that, I think the adaptation is quite easy into using this. But I do agree that there is a barrier to entry, which is part of what this group is trying to figure out, which is how do we build a community around this and make it supremely useful to everybody in a way that doesn't diminish the technological part like you're talking about. So.
And if I can follow up on that, I think people get, there's a reason why we format information the way we do, like in publications. And although we may change format, so like we've moved beyond PDF and that has some web-enabled ways to digest journal articles, people still want to see the narrative written out in the same basic pathway. You want the introduction, then methods, then you get the discussion and conclusions. So I guess what I'm saying is that if to reach that broader audience, to address usability, you might have to generate static views of analytical outputs that are situation dependent. Kind of like when you're doing a Google search now, you get all sorts of web pages that respond directly to what you're looking for, like 10 best race cars. You'll find 100 top hits on Google that mimic your search almost exactly. And then when you go to those websites, it's clearly created by a robot, right? So, but that's the way that people have come to digest web information. So I think creating these kind of static endpoints and indexing them and you could even think about doing that for in specific emergency responses, like for a wildfire, and Google will direct all traffic to that website that could be supported by this technology. But that takes away some of the interactivity and the the expertise that's needed. It is a special expertise to be able to query a relational database or do any kind of data query like that most of the population doesn't have. So to reach that next level, to get to the public, I think you need to think about the pre-digested information.
I totally agree with you, Jonathan, that building the UIs for accessing the KnowWhereGraph, that presents challenges in and of itself. I did post a little follow-up in chat there. We realized we needed to provide some ways to interact with the KnowWhereGraph aside from a Sparkle endpoint. And I think what you saw was several of the applications that we've developed to meet the specific needs of some specific stakeholders. But I think that there's also huge, aside from not, minimizing the importance of and challenge of developing good user interfaces, the graph itself, is very standard. It has a very standard structure. It follows a consistent W3C set of recommendations. So developers can go at it and develop, interfaces that best serve the needs of their stakeholders. I think that's the real difference between that and, some sort of a complicated entity relationship schema, which we've probably all had to deal with, and how that can constrain, how you develop a user interface there. But it is, I agree, building UIs for graphs is still an exciting area. Well, thank you very much, Anna Lopez-Carr and Colby Fisher, and all of those who attended for seeing how the KnowWhereGraph is currently developing. Thanks all.